Oh yeah. I think we are back. Yeah, I think we are back. Yeah. It was network issues. Yeah, network issues. 11 chip, please send the link. Please send the link to the 11F. Please send the link to the 11F learners if you have them in your WhatsApp, and then they can share it. Okay, please send the link, and then I'll just wait 5 more minutes for everybody to join. Okay. Uh, yeah, I'll just wait 5 more minutes. Okay, so far we have nine. That is watching. Please share the link with the 11F if you have them on the WhatsApp group, and then I'll just wait like 2 more minutes for everybody to rejoin. Hello, we're going to start now. I can see the WhatsApp group. Yes, Karana Koma. No, we'll start now. Just 2 more minutes. Let's just give them 2 more minutes to see. Let me see. Now it's 12 that is watching. Just 2 more minutes for everybody to be online. Yeah, we're going to start now. Yeah, so far, let me see. Yeah, this is where we got disconnected, where we are solving for X. That's where we got disconnected. Yeah. That's where we got disconnected. Okay, and then let me just see now how many people we have. We have 12. We have 12. Yeah, so I think we can continue. I think we can continue now. We have 13 that are joining. I think we can continue. Then others will rejoin as we are continuing. So yeah, let's continue. So remember here we are solving for x. We already solved for y. We said y is equals to 2 or y is equals to minus 4. And then if that is the case, then it means we are going to start by saying where we see y, we need to substitute what? 2. So I see y here is 2 plus 2, this is equals to 4. Or another option is this one, which is x plus, not x plus, but let me just rewrite this. This is x is equals to y plus 2. Then x is equals to, I see y. When we see y, we're supposed to substitute minus 4. That's minus 4 plus 2. Then our answer will be negative 2. Therefore, we have solved simultaneously for both x and y. So tomorrow, again, for simultaneous, we need to have 4 solutions. We need to have 2 answers for y and 2 answers for x. To recap what I did here, first, you need to have equation number 3. It's up to you whether you solve for y or you solve for x to form equation 3. But after we have formed equation number 3, we need to substitute this equation number 3 back into equation number 2. Don't substitute where you found this equation number 3. Don't substitute it where you found it, because we got it, we derived it from equation number 1. After we have substituted, you know what? Two brackets, you FOIL, you simplify, you factorize. But I suggest that you don't factorize, you use a quadratic formula. Remember, a quadratic formula will give you these answers straight directly. Then after finding your y, you go back to equation number 3 where we made x the subject of the formula. You substitute it here on y. Where you see y, you substitute 2. Where you see y again, you substitute what? The minus 4. And then you find your solutions. And yeah, so I hope that was a bit clear. And then let's go to this one, 1.3, where we need to make the subject of the formula, what we call lateral equations, where we need to make a formula to be the subject. We need to make a variable to be the subject of the formula. So let me just quickly erase here, and then we can start here. So we are given the following here. We are given that S, so let's read the statement. It says the surface area of a cylinder closed at both ends. It is given by this formula over here. S is equal to 2 pi r squared plus 2 pi r h. So 2 pi r squared plus 2 pi r h. So when then it says where r is the radius and h is the height of the cylinder. 1.3.1 says we need to make h the subject of the formula. So let's make h the subject of the formula. Where's our h? Here's our h here. We need to make this the subject of the formula. Meaning, we need, after we have simplified everything, we need to have h is equals to da 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 da. Then we have made h to be the subject of the formula. And then how do you make h the subject of the formula? You start again. We need to take this one to the other side, because this part and this part, they are separated by what? By the addition. And when we have this scenario, it means what we want. What is it that we want? Remember, we want h. And the h, this here, what we want, it is contained in this part of the equation. So we can take 2 pi r squared to the other side, meaning when we have s minus 2 pi r squared, this is equals to 2 pi r h. Then, because we want to solve for what? For h, and in this case, h it is combined through multiplication with r, with pi, with 2. Therefore, how can we isolate h when we have this multiplication here? When we have these terms combined with the multiplication, you can do what? We can divide. It means I'm going to divide by 2 pi r. I'm going to divide by 2 pi r. Then this 2 pi r will cancel this 2 pi r. Then ultimately we are left with h is equals to s minus 2 pi r squared over 2 pi r. And then we can simplify this further by separating our terms. How can we separate our terms? Remember, in mathematics, when we have something like this, if we have x minus 2, let's say over y, this can be rewritten as x over y minus 2 over y, meaning the denominator it will be shared between x and 2. That's exactly what we can do here. Our denominator, which is this, it can be shared between s and the 2 pi r, meaning s over 2 pi r minus 2 pi r squared over 2 pi r. And then we ultimately are going to have s 2 pi r minus the 2 will cancel the 2, the pi will cancel the pi, the 1 r will cancel the 1 r here, will be left with r. But for this over here, it's a simplified solution. We have made 8 to be the subject of the formula. And then after that, the question continues on to say, continuing to say, hence determine the height of the cylinder. We need to determine this height. If the S is 150, radius is 3, round your answer to 2 decimal places. Round your answer to 2 decimal places. Therefore, how do we do that? And then this is how you do it. You simply say H is equals to, remember they said S is 150 to 5. They said the radius is how much? 3. 3 minus the radius, which is 3. And then when you put this in a calculator, let's take out our calculator and let's see, it's 150 divided by 2 pi, then let's put 3 minus 3. Then our answer is 4,96 because we need to round off to 2 decimal places. Therefore, our answer is 4,96. And this over here is our solution. And then, ladies and gentlemen, let's come to the nature of roots. Let's come to the nature of the roots. Let's come to the nature of roots. We'll remind you with the nature of roots. This is what we have. If you remember this diagram, I did it in class with my 11P. Let me just cut this and then go and paste it. I forgot. No, I think we can do it here. Let's check if we can write here. No, I can't write. Alright, but it's fine. Let me just try to remind you. The nature of force, remember, we are talking about the discriminant. The discriminant, and we are saying the discriminant. Okay, but I'm gonna need to write, so let me just type this, and then let me go and paste it here. Remember, nature of roots, we are dealing with the discriminant, and we are saying that the discriminant is equals to what? B squared minus 4AC. And then remember, we are saying that if the discriminant, if the answer that you get is less than 0, meaning if it's a negative answer, the roots for your graph will be imaginary. They will be what? Non-real. This means your graph, your parabola, when you sketch it, it will not touch the x-intercept. It will simply fly. It will be here. It will not have the roots, the x-intercept. However, if, let me check out the highlighter, if the discriminant it is greater than 0, what does this mean? This means that the roots, they are what? Real. The roots, they are real. So if the discriminant is greater and equals to 0, the roots are real. Then if the roots are real, then we can have two options. We can have where the roots are unequal, like here. If the roots are unequal, then the discriminant will be greater than 0. However, if the roots are equal, then the discriminant will be equals to 0. So what we mean here by unequal roots? Unequal roots simply means something like this. Maybe here you have 2 and then square being a perfect square. Or you can have the discriminant not be a perfect square. If it is not a perfect square, then the roots they are irrational. But however, if the discriminant is a perfect square, then the roots are rational. Remember, rational numbers, these are numbers that can be written in the form of a fraction. Irrational numbers, these are numbers that cannot be written in the form of a fraction. So you must remember this diagram because it will not be given tomorrow. So now let us go back to our question. And this is our question here. Uh, Our question now, the first one here, 2.2, it says, determine the nature of roots if you are given this. Determine the nature of roots if you are given 2x squared plus 3x minus 5. This is equal to 0. Remember, the discriminant, to find the nature of roots, the discriminant is equal to b squared minus 4ac. Where for b, it's 3 squared minus 4, and then for a is 2, and then for c, it's minus 5. Then 3 to the power of 2, this will be 9, and then minus 4 multiplied by 2, it's minus 8. Minus 8 multiplied by 5. Now, let's just put everything on a calculator. Let us not complicate life. 3 brackets 3 squared minus 4 brackets 2 minus 5. There's the bracket. This is 49. It's 49. So how do you describe the nature of roots? The nature of roots here, we can see that they are real. How do you know they are real? Because our discriminant, it is greater than 0. But if you check here, our discriminant, it is greater than 0. Therefore, it also means the nature of roots, they will be what? Unequal. But also if they're unequal, because 49 is a perfect square. 49 is a perfect square of what number? Of 7. Therefore, if it's a perfect square, what does it also mean? Means now the roots, they are lastly, they are what? They are rational. So this is what we want to see for those formats. Okay, and then let's go to 2.3. Now we have two people are watching. I don't know why though the numbers keep fluctuating, or maybe people are also having connectivity issues like myself. But it's fine. Let us go to 2.3. Let's go to 2.3. 2.3 says, for which values of k will kx squared minus 6x plus 1? Okay, so let's just rewrite that one. It says, for which values will kx squared minus 6x plus 1 equals to 0? And then let's see. First it says, for which values will this have equal roots? Remember, for equal roots, the discriminant, what must happen to the discriminant? The discriminant must be equal to 0. So, for equal roots, the discriminant must be equal to 0. Remember, the discriminant is given by what? By b squared minus 4ac. This is equal to 0. What is b? Here's our b, minus 6. We take it with a sign. minus 6 squared minus 4. What is a? Here's our 8 is represented by the letter k. By the letter k. Remember, you don't take the x, you leave the x alone, you take the coefficients only. And then c, it is represented by the 1, and this is equals to 0. Therefore, this 6 to the power negative 6 to the power of 2 is 36. Minus 4 by k by 1 is minus 4k. This is equals to 0. And then take 4k the other side. 36 is equals to 4k. Divide by 4. Divide by 4. Therefore, k will equals to. Let's look what is 36 divided by 4. 36 divided by 4. This is 9. That means the value of k, which will make this expression over here to have equal roots, that value of k, it will be what? 9. That's what we're looking for. Now, 2.3.2, they say for non-real roots. Remember, for non-real, our discriminant must be less than 0. The discriminant must be less than 0 then. So let us come back here. The discriminant must be less than 0. Now, for non-real, the discriminant must be less than 0. Remember, the discriminant again is given by b squared minus 4ac less than 0. And then for b, again, it's negative 6 squared minus 4. A, it's k. C, it's 1. This is less than 0. Therefore, this will be 36 minus 4k less than 0. 36, this is equals to 4k. Divide by 4 again. This would be 9k. Now, what does this mean? This means all the numbers that are less than 9 will make this expression over here to have a non-real root. So here on k, if you put any number which is no greater, because this k must be greater than 9. Any number which is greater than 9, which you substitute here, it will make this equation to have non-real roots. So that means if you put 10, 11, 12, 13, and you find the discriminant, you will see you get an error. You will get an error. This is what this means here. Okay, so question 3, 23 marks is done. And then I think we can now go to question number 3. Oh, this was question number 3, in fact. Let's do a bit of question number. Let me see which one can we go here. The log. We've done a number of logs, but let's see which one can we take it. Yeah, let's take the exponents, simplifying exponents, because that way you can score easy marks. Let's take this simplifying without using a calculator. Okay, let's start with the first one. Let me just rewrite it. We have 3bn, we multiplied by b3, we multiplied by b3n. Remember, the laws of exponents, what do they say? When you multiply the same base, you add the exponents. When you divide the same bases, you minus the exponents. Those are the basic laws of exponents that you need to know. So in this instance here, we can see that we are multiplying b, we are multiplying b, we are multiplying b. Since we are multiplying the same exponent, the same basis, we must add the exponent. This means here we are going to have 3b n plus 3 plus 3n, which will be if you look at the like terms, this n will add with the 3n such that we have 4n, and then the plus 3 will be alone. Okay, you must have b here, and this will be your solution. And I think this is 2 marks. So let me just put, yeah, 2 marks. Easy marks. Let's go on again to the second one, which is 3.1.2. Let me just look at the question. We have 15x 10 divided by 5x 4. We are dividing here. So it's like saying 15x 10 divide this by 15x 4. We are dividing the same base. Remember, when we are dividing the same base, we subtract the exponent. So in this case, 15 divided by 5, I think this would give you 3. Then when we are dividing the same base like x and x here, the exponent of the denominator will minus the exponent of the numerator. We have x 10 minus 4. The final answer will be 3x to the power of 6. That's your 2 marks again. Easy marks for tomorrow. Right, let's move on again to, I don't think this question came out right. I think this question for 3.1.3 was supposed to be like this. It was supposed to be root 5 minus root 3. Close the bracket. It was supposed to be root 5 plus root 4. I think that's how it was supposed to be. That's how it was supposed to be. Because when it's like this, it doesn't make sense. It's easy. Let me just check how many marks. Okay, but I'll do both. I'll do both. Suppose the question it was in this format. How do you simplify? I will remind you. When you are dealing with sets, when you are multiplying the same sets, when you are multiplying the same sets, square root of a multiplied by the square root of a, the answer is what? It's a, because root multiply the root, they remove one another. However, when you multiply root a, maybe multiply by root b, these two, they need to multiply one another, and then you maintain the square root, you keep the square root. So that is the basics that I will remind you of. So now let us go back to this one. Root 5, because there are two brackets, we need to look for 5. Root 5 times 5, root 5. The answer is 5. Root 5 times 4. Remember with this one also, you don't have to complicate your life. Multiply 5 multiplied by 4 is 20. You can also do it on a calculator. And simply say root 5 multiplied by root 4. The answer is 2 root 5. The reason why it's 2 root 5 is because the calculator simplifies the square root of 20. And the square root of 20 is 2 root 5. And that's how we're going to see we use the calculator. So this one it will be 5, it will be square root of 20. And then root 3 multiplied by this one will be negative root 15. Then root 3 multiplied by 4, the answer will be minus root 12. And then you have 5. And then when you simplify the square root of 20, simply do it on a calculator is 2 root 5 minus root 15. Can root 15 be simplified? Let's try. No, it cannot be simplified. It's minus root 50. Root 12. Can root 12 be simplified? Let's check. It's 2 root 3. It's 2 root 3. Now, when you look at this here, there are no like terms. It means this over here, this is your final answer because there are no like terms. However, what if the question it was like given as it is? What if the question it was root 5 minus 3 multiplied by root 5 plus 4? It's always supposed to be the other problem. What if the question is supposed to be like that? This square root, when it multiplies with the square root, what do you think will happen? You can also do it on a calculator just to check your answer. 5 minus 3, this bracket, this bracket. This will multiply it again with square root 5 plus 4, close the bracket. The answer is 3 root 2. How did the calculator get to that part of 3 root 2? How did the calculator get that? This is what it did. It said this root multiplied by that root over there. When you multiply two roots, or I'm thinking of another way of doing it, but we are going to have a negative under the square root. If you do it, okay, so let's do it just so simple. 5 and 3, these are like terms. That means we can simply say 5 minus 3. And the answer that we will get is what? Is 2. What is 5 plus 4? The answer there is what? It's 9. Therefore, root 2. What is the root of 9? The root of 9 is what? Is 3. Then 3 multiplied by this 2, the answer is 3. Root 2. Yeah. So we are having like terms underneath the square root. You can simply add them, minus them, and get your answer. And then let's go to this one over here for 5 marks or 6 marks. Bracket 4x plus 1 multiplied by 3x plus 1. This is all over 24x plus 2. Now with this one, first take your bases. Remember, your bases most of the time they should be written as prime numbers. How can you write 4 as a prime number? You can write 4 as 2 to the power of 2. But remember, you still have this x plus 1, x plus 1. Is 3 a prime number? Yes, leave it like that, 3x plus 1. This is all over. Is 24 a prime number? No. How can you write 24 as prime number? You can write 24 as 24. That means you have 2x plus 2 times 3x plus 1. This 3 will fall here, this 3 will fall there. That means you have 2 3x plus 6 multiplied by, remember there's a 1 here. 1 will have to fall here, and there it will be 3x plus 2. Right? Now, once we are here, if you look at this, we are now dividing the same base. This base, it is divided by this base. And then this base over here, it is divided by this base over there. If you remember, when you divide the same base, you can do what? You can subtract the exponent. That means you have 2x plus 2, and then the exponent of the denominator is minus, the exponent of the denominator is minus. Then you have multiply by 3x plus 1. Again, what does this mean? The exponent here is minus, the exponent there is minuses. Then final answer will be 2. Then 2x minus 3x, you get minus x. 2 minus 6, you get minus 4. Multiply by x minus x, you get 0. 1 minus 2, you get 3 minus 1. And then this can be simplified further as, let me just check, as 2 minus x minus 4 multiplied by 1 over 3. Yeah, but I think this step here is unnecessary because the question it said we should not leave our answer as positive exponents. Or did it? Let me just check. No, this is simplified. So you can leave your answer at this part, it will still be correct. Fine, and then now let's do just a bit of logs. Let's do a bit of logs, and then let's see a bit of logs. Let me take this one. Let me take this one, and I'm also going to do this one over here. In fact, let me do this entire question, and I think we'll be done for the night. Now, let me simply do this last one. So 3.2, the question said we must simplify. Remember, when you simplify the logs, the coefficient of the logs here, we want it to be 1. If it is not 1, you need to apply that rule of the logs. That says you need to take this coefficient, you take it to this side where it will become the exponent. After we are done, just go back to your classwork book and revise those rules of the log. So let's check here. In this case here, is our coefficient 1? The answer is yes, so let's leave it as it is, as log 36 plus. Is the coefficient here 1? The answer is yes, so for now let's leave it as it is, as log 25 minus, is the coefficient here 1? The answer is no. Let's apply the rule of the log. The rule of the log will be log 3 to the power of what? 2. And then yeah, we will see where this leads to. Remember now, the rules of the log says what? When you add, you need to do what? You need to multiply the log. So meaning we're going to have log 36, this we're going to multiply it by 25. And then if we are minusing, we need to do what? We need to divide. 3 to the power of 2, this will be log, we need to divide it by 9, because 3 to the power of 2 is 9. And now what will be 36 multiplied by 25? So let's just calculate 36 multiplied by 25. This is 900. Therefore, we're going to have log 900 divided by log 9. Now remember, if the base is not given, it means the base is the same. The base is the same. And then let's try and rewrite this 900. We can rewrite the 900 as that. Okay. Alright, yeah, this is where I made the mistake. We needed to simplify these ones first. Okay, I see my mistakes. That was not written up. That was not written up. And remember, with these logs, you can take your answer on the calculator. Okay, now I have closed my calculator. You can check your answer with a calculator first. You can have log, another log. We can have log 36 plus log 25 minus 2 log 3. And the solution will be 2. That means we want our answer to be 2. Fine, we have checked the exponents. We here log 36 plus log 25 and this was minus 2 log 3. Log 36, this 36 over here, it can be written as a prime number of what? This 50. Why does my calculator keep increasing? 36, I think it's 6 to the power of 2 here. I don't have to do it. 36, it's 6 to the power of 2 plus log 25, it's 5 to the power of 2 minus, and this one it will be log 3 to the power of 2. Let me check then what else can you do here. Then you can apply the rule, take it that side, you can have 2 log 6 plus 2 log 5 minus 2 log 3. That means in this case, when you are adding, then you can multiply and have 2 log 6 multiplied by 5. This will be divided by 2 log 3. Then this will be equals to 6 multiplied by 5. Let's check. What is 6 multiplied by 5? It's 8. That means here we're going to have 2 log 80 divided by 2 log 3. The 2 will cancel the 2 over there. And then 30 divided by 3. Let's check what is 80 divided by 3 is 10. That means here then we have log 10. But remember, if the base is not given, the base is 10. And log base 10 to 10, then uh, the answer is 1. Why am I not getting 2? What did I do? What did I do? What did I do? Oh, okay, I'm not sure where I went wrong. And then let's quickly do the solve for x, the solve for x of the logs to this one over here. X of the logs to this one over here, which is log base 3x plus log base 3x minus 2 log base 3 of 3. Again, if we are adding, we apply the rules of the logs. First, we must multiply the numbers. Remember, the numbers are these things. This one and this numbers. The numbers are these things. This one and this one. We need to multiply them. It means we're going to have log base 3 x, this x, multiply by x minus 2. Now this part over here, it will give us what? 1. When the base is the same as the number, we get what? 1. And then remember, we need to get rid of the log. Once we're in this situation here, we need to apply that rule of the log, which says if this is the base, the base 3 needs to come this side. Meaning we're going to have x minus 2, this will equals to 3 to the power of 1. The 1 becomes the exponent, while this base over here becomes the base. Then when you find this, it's x squared minus 2x, this is 3. Which means ultimately this one it will be x squared minus 2x minus 3. This is equals to 0. Two brackets, that you can use a quadratic formula. X3, 1 minus plus. Apply the 0 factor law, x is equals to minus 1 or x is equals to 3. That's just the solve for x. Just go back to the rules of the law. And then this last one here, that says 3 2x plus 2 is equals to 192. Again, we need to get rid of this 3. This 3 which is combined with the multiplication here, needs to go. Divide by 3. Divide by 3. Then you'll be left with 2x plus 2. Then 192 divided by 3. Let's check what is 192 divided by 3. 192 divided by 3. It's 64. And then once we're here, we need to make our bases to be the same. This base needs to be the same as this base. Meaning, how can you write 64 as a base of 2? Is 2 to the power of 64. Let's check it quickly. 64 equal sign 2 to the power of 6. And then once the bases are the same, you cancel the bases, you drop the exponent, then you have x plus 2 is equals to 6. Take 2 to the other side, it's 6 minus 2, then x is equals to 4. You have solved. I think that's it on solve for x. And then I will just need to revisit this one quickly. I will send it on the group before 10 o'clock. And then I think, yeah, I'm getting tired now. I'm getting tired, and I think we have covered the rest of this paper, or the majority of it. Yeah. Remember, this paper will be similar to the one that will be there tomorrow. And then I will also do another live session on Saturday and Sunday again for paper 2 revision.